Greetings everyone, this is Priya and today I'll be beginning the second lecture on trigonometry, that is, we'll begin with the transformation formula. So transformation formulas, as you must be aware of AB formulas, wherein sine of A plus B plus sine of A minus B is given by 2 sine A cos B. Okay, this is first transformation formula. If you come down, then sine of A plus B, only the change in sine of A minus B will be what? 2 cos A sine B. Okay, then we have 2 for cos as well. There is cos of A plus B plus cos of A minus B will be 2 cos A cos B, and there is 1 cos of A minus B minus cos of A plus B will be 2 sine A sine B. This last formula can also be written as cos of A plus B minus of cos of A minus B. Then this formula comes out to be minus 2 sine A sine B. This is just the form of fourth formula, so don't confuse with it. And these all formulas are derived from, you know, sine A plus B is what? Sine A cos B plus cos A sine B, right? Similarly, if you substitute sine of A minus B, you will get another value, and there will be one value subtracted, like sine of A minus B will be sine A cos B minus cos A sine B. Now the first formula, if you see, is what? Sine A plus B plus sine A minus B. That means they are adding these two terms. We are cancelling this out and we are left with 2 sine A cos B, right? So similarly, all these formulas can be derived, and this is used majorly in our trigonometric chapter. So you guys can note it down till we move on to the next. So let's move on to the next topic, that is C and D formula of sine waves. So if I move to C and D formula, we have 4 formulas in this as well, which are in the form of C and D. You must be familiar with. I'll start with the first one. So sine C plus sine D will be 2 sine C plus D by 2 cos C minus D by 2. If you move to second, that is sine C minus sine D, that will be 2 cos C plus D by 2 sine C minus D by 2. We corrected. Yeah. Okay. The third of this kind is cos C plus cos D, that is given by 2 cos C plus D by 2 cos C minus D by 2. Okay. And the last one of CD formula is cos C minus cos D, that is 2 sine c plus d by 2 cos c minus d by 2. Alright, so we'll move on to trigonometric ratio of multiple angles now. So you must be familiar with these three formulas, that is sine 2 theta, then we have cos 2 theta, and last is tan 2 theta. So if you consider these three formulas, this first one can be written as 2 sine theta cos theta. It can be written in the form of tan theta as well, 2 tan theta upon 1 plus tan square theta. These are the two formulas. Then we can move on to cos theta, that is 2 cos square theta minus 1. It can also be written as 1 minus 2 sine square theta, right? And the last one, if you want to write it in the form of tan square, so it will be 1 minus tan square theta upon 1 plus tan square theta. Okay, moving on to the last one, tan theta can be given as 2 tan theta upon 1 minus tan square theta. So these are the three trigonometric ratios for multiple angles. Now let's move on to the trigonometric ratios for submultiple angles. So we have sine, okay, herein I'll like to mention sine 3 theta as well, because that is also used in our syllabus. So sine 3 theta will be given as c3 sine theta minus 4 sine cube theta. Okay, it can be written as 4 cos cube theta minus 4 3 cos theta. This is 3, and tan 3 theta can be written as this is cos 3 theta. Now we are mentioning tan 3 theta. It can be given as 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. Let me write it more clearly. 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. So let's move on to the trigonometric ratios of submultiple angles now. So for that, I'd like to mention first formula as sine A. You know, sine theta was what? 2 sine theta cos theta. So if you put 2 theta as A, it will become 2 sine A by 2 cos A by 2. If I'm not wrong, is this clear? And if you again put it in the tan formula, it will be 2 tan A by 2, 1 plus tan square A by 2. Am I making my point clear? Then we have cos theta similarly. So these are all derived from the previous formula we have discussed. So cos theta will become 2 cos square A by 2 minus 1, or you can also write it as 1 minus 1 minus 2 sine square A by 2, or lastly 1 minus tan square A by 2, 1 plus tan square A by 2, right? 1 plus tan square A by 2. Alright, then we have tan theta as well. So you can write tan theta as 2 tan A by 2, 1 minus tan square A by 2. Okay, then we can discuss few more formulas. That is, fourth one I'll mention 1 minus cos theta. That means 1 minus cos 2 theta was what? 2 sin square theta. If you derive from the previous formula only, so it will be 2 sin square A by 2 here. Then fifth is 1 plus cos theta A. That is 2 cos square A by 2. Then 1 minus sin A, 1 plus sin A. We'll write these two formulas as 1 minus sin A is cos A by 2 plus, this is minus cos A is sin A by 2. Let me cut this formula. Sixth one is 1 minus sin A is cos A by 2 minus sin A by 2 ka whole square. And seventh is 1 plus sin A as cos A by 2 plus sin A by 2 ka whole square. Am I making my point clear here? So these are few formulas which we used majorly. Now let me move on to the next slide. Just make the correction here, and these all formulas can be derived. If you guys have problem in any formula, we can just derive it and get to the solution. Alright, so moving on to the next slide, that is values of some special angles. If we discuss values of some special angles, so you should know the value of sine 18 degree, that is root 5 minus 1 by 4. This will be equivalent to cos 72 degree, because you know sine theta is equal to cos 90 minus theta. So from here, then this is the first value. Then you should know the value of cos of Z. Okay, let me start again. I'll mention cos of 18 degree is root 5 plus 1 minus 1 by 4 is equal to cos 72 degree as sine theta is equal to cos 90 minus theta. Then we have sine 18. Then we have cos 36 degree, that is equal to 10 plus 2 root 5, take it in root upon 4, that is equal to sine 54 degree, 54 degree, sorry. Again, same. Then third one is sine 36 degree is equivalent to 10 minus 2 root 5 upon 4, that is equal to cos of 54 degree answer. Okay, so these are few trigonometric values. Now we can move on to the trigonometric equations, which says if sine theta is equal to 0, then value of theta will be what? N pi, where n is a number. You can substitute, because you know the sine graph, it is like this. So 0, pi by 2, pi. At pi, then it will be 0. Then again, if you see 2 pi, it's 0. So you put on values of n, you get a sine 0 at all as interval. So this is first. Then you can move on to the second, which says cos theta is equal to 0. Then theta will be 2n plus 1 pi by 2, because it has an interval of pi by 2. Theta cos is 0 at pi by 2, as we know. So we can substitute the values of this. Like you can start with 0. If you do 0, it is pi by 2 exactly. Then you put 1, it will be 5 pi by 2. At all those intervals, sine cos theta will be 0. Alright. So then you can move on to relations between angles and sides of a triangle. So let us consider in any triangle ABC, if you see, this is angle A and opposite side is A. This is angle B, opposite side is small b, and this is angle C, opposite side is small c. Okay, so the sine formula will be A upon sine A is equal to B upon sine B is equal to C upon sine C. Understood? If you go to the cos formula, it will be cos A will be B square plus C square minus A square upon 2BC. Cos B will be C square plus A square minus B square upon 2CA. Then we have cos C, that is equal to what? A square plus B square minus C square upon 2 of AB. These are the formulas we'll be using in this chapter. I hope you understood all of them. If anything is not clear, you can just comment on the doubt section, and then we can start this chapter with some problems. Thank you, guys.